So helium walks into a bar, the bartender says, "Hey, we don't serve noble gases here." And helium doesn't react. Okay, here we go. This is lesson 28, and it is on the creation of an esterification reaction, but it's a little bit more than that. It's about linking chemical reactions together. So the question at the top of the page there is how to make ethyl ethanoate from ethene plus some other chemicals. So it's not like there's one sort of magic reaction to figure out. You have to figure out a sequence of reactions, and you have to like adjust them, right, so that they roll out properly. So I left a hint there at the top there, and it says start at the end and work backwards towards ethene. It's just easier to start at your product and go back to ethene than start at ethene and go to your products. It's like those little maze puzzles. You know, it was often easier to work backwards to, you know, you start at the end and you work backwards to the beginning, as opposed to making all the mistakes in there. It's the same idea. All right, so here we are, and those are just some of the questions that you guys will be attempting before. But let's get to the end, which is ethyl ethanoate, right, which is an ester. So let's find out what is the reaction that creates ethyl ethanoate, and that's going to leave a clue as how we're going to get back to ethene, right? Just easier, again, going that way. So this is me splitting apart ethyl ethanoate and its companion water, because it is an esterification. We can break that apart into ethanoic acid and ethanol. All right, so we've got the carboxyl functional group there and the alcohol functional group here, and you know, the OH from the ethanoic acid reacts with the H from the alcohol, and then those other two pieces slide together. Okay, so we're still not there. I mean, we still have to sequence this properly. Oh, and I forgot about the dehydrating agent there. There's the H2SO4. All right, well, how do we make ethanoic acid? Because we don't really have a reaction to take that from ethene, but we know where it comes from ethanol. We know it's the oxidation of ethanol. So we can take some ethanol, haven't figured out where that's going to come from yet, and we're going to oxidize to make ethanal and oxidize that again to make ethanoic acid. There was a 2-electron oxidation to the aldehyde and a 2-electron oxidation to the carboxylic acid. All right, so we're almost there. So we just have to figure out how to get ethene into ethanol. And if you sort of think back in your little library of reactions that we've done there, we've done quite a few reactions now, all right? A lot of formations, redox, substitutions, additions. So we've done a lot of reactions right there. So there is one that we've done, and that would be, and you can even pause the video now if you wish and see if you can figure that one out. We have done it. All right, and that reaction is an addition reaction. If we do the addition of water into ethene, right, so the double bond right over there, and with an acid catalyst, we'll produce an alcohol, right? And this is not a Markovnikov addition, just because there's equal hydrogens over here, so it doesn't really make any difference. The OH will end up randomly on one side, and the H will end up on the other side. So there is how we create ethanol. So to put all this together, so you would take some ethene, add water to create ethanol. You would take a portion, like half of it, take half of the ethanol, and you're going to oxidize that to the ethanoic acid. Then you can add these two products together with some sulfuric acid to get ethyl ethanoate plus water. So there is the correct sequence, and this is called a synthesis reaction. Okay, so yeah, so this is what synthesis chemists do, by the way. If you watch Breaking Bad, you know, Walter White would have been an excellent synthesis chemist. That would have been his thing. All right, there you go. So a couple of problems there, and you can see if you can figure those out and figure out those sequences. Again, easiest, start at the end, work back to the beginning. All right, give that a whirl.